So an experiment was carried out to determine the percentage of iron in an iron salt, right? So what that means is that sometimes you go to the pharmacy and you buy an iron tablet. So you have a tablet here, and the tablet, it might be, I just giving you a figure here. It might, let's say, be 20 milligrams, right? It might be a 20 milligram iron tablet, but really and truly, it is not actually 20 milligrams of iron inside it, right? For all you know, it might be 18 milligrams of actual iron that is inside it, right? So this is an experiment. We are going to determine the percentage of iron in a sample in an iron salt, right? So here's what's happening here. Oh, they told you the mass of the iron tablet. So it's 0.500 grams of a sample of iron salt is placed in a conical flask. Now, when you have experiments like this, please understand what's happening. This is my conical flask. You're going to put an iron tablet inside there. To it, you're adding 25 milliliters of sulfuric acid. So try to visualize what's happening here. And those of you doing it privately, try to understand what's going on, right? So here we have 0.500 grams of my iron salt, right? So this is an iron salt. And what I'm adding to it is 25, so it's 25.0 milliliters of dilute sulfuric acid. So this is H2SO4. Sulfuric acid is being added, right? Right, so you're adding 25 mils of dilute sulfuric acid. You're also adding, right, so there's more things you're adding here now. You're adding 10 milliliters of phosphoric acid. So that's H3PO4, right? And you're also adding 8 drops of an indicator, right? So look at all the things you're adding to this. So you're adding 8 drops indicator, right? Now you're reading the question a little bit by a little bit to make sure you understand what's happening. The contents of the flask were mixed and titrated against 0.2. So you're titrating this now against potassium dichromate until the endpoint was reached, right? And this is important here. They gave us a formula, right? You're not expected to learn off some of these formulas, right? They give you the formula here. So what is happening is that we are titrating. So there's a titration taking place between everything inside this here in this conical flask versus potassium dichromate. So K2Cr2O7, right? That's my orange. So this is orange, right? So you're titrating this orange liquid with whatever is in that conical flask, right? That's all they told us so far. You all follow what they just said they did?
Yes, yes.
Yeah.
Right? So question 1, try to break down question 1. Question 1 could be a little difficult for you guys. So now let's see what they gave us. Oh, okay. So now we have titration results here now. So it shows the burette readings of the initial and final volumes of each titration, right? So we've done a question like this in class. So they said list the apparatus that would be necessary to carry out this experiment. So all CXC trying to ask you in SMART here is, here what do I need in order to perform this titration? Can anybody tell me what do I need?
So in a burette, a pipette.
You need a burette, right? You're going to need a pipette, yeah. What else?
So the iodine.
Iodine.
Okay, never mind.
So we're doing a titration here, right? I'm hoping that you all at least did a titration before. The only people who may not have done this would be those who do it privately, right? So here's what you need. You need to make sure you have a retort stand. Remember, that's what holding up the burette, right? So you need a retort stand. You need a burette. You need a pipette. You might need a measuring cylinder because you need to measure the acid and those things, right? You need something to measure the mass of the tablet. So you need an electronic balance, right? And you may need a conical flask in order to perform the titration. So let's write down all the things that we need. So we need a retort stand, right? You need a burette. You need a pipette, right? We need a conical flask, we said, right? That's what we're gonna, remember, when you're doing titration, you are mixing your mixture when you are adding things from the burette. So you need a conical flask to do it in, right? You might need a measuring cylinder, right? Because if you notice in the question, if you go back here, remember you added acid, you added 25 mils of sulfuric acid, 10 mils of H3PO4. You need a measuring cylinder in order to do that. So a measuring cylinder, right? And also we need to measure the mass of the tablet. So you need an electronic balance. So does this apparatus make sense?
Yes, sir.
Right? And it's 2 marks. So you just give any 2 CXC will probably give you that anyway. Now, let's see what we're going to do here now. So we did a question like this in class before, right? This is one of the most popular types of questions you could get, right? So let me just, I want to bring the picture of the, hold on, I just bring in the picture of the burette readings closer so we can fill out the table, right? And by the way, look at how much marks for this. This is, honestly, if you get something like this, you should be happy, right? This is like 9 marks just to follow this table, 9 marks just to follow this table. So let me get back my pen. So we have the first titration here, right? I want you all to look at the diagrams and tell me in this, for this cell here, what value am I going to put there? What is my final volume?
The 21.95.
21.95 sounds about right to me.
Same thing.
21 point, let's see here. Yeah, that's 21.95, right? So what you're going to put, that's my final. So you're going to put 21.95. Look at, you get 9 marks just for reading off these burette readings, right? Those of you who are doing it privately, when you do the titration, you are actually looking at the burette. So what they've done here, they've given you pictures of what it's looking like, right? What is my initial volume in this case here? What am I going to put in the next cell?
So would that be 2?
Right, but remember, always give your values to 2 decimal places, right? So it'll be 2.00. So this here is going to be 2.00, right? And what you're going to do, the volume of solution used, we just need to subtract those 2, right? And when you subtract that, this is going to be 5, and this is going to be what? 19.95, right? So that's 3 marks again just for that there. Next titration now, we're looking at the second titration. What is my final volume? When you all read it off, what you get in there?
Yes, 21.85.
21.85. Yes, that's sounding right to me. Make sure everybody can read that. 21.85. What is the initial volume in that case there? How much?
1.85.
1.85. Yeah. 1.85. So this here is 1.85. And when we subtract this, we're going to get 20.00, right? Let's talk about the third titration now. What is that reading there on that burette?
19.5.
Yep, 19.5. 0. And what is my initial reading?
1.5.
0.5.
1.50. Right? When you subtract this, you're going to get 18.00. And look at that. You just get 9 marks here just for reading off some bureau readings. That's it. Right? So if you get a question like this, you should be smiling in the exam, man. Right? So those of you doing privately, please pay attention to these types of questions because those are the things you can actually get in the exam. Now let's see, what do they want us to do now? They said using an asterisk to indicate the titration data that should be used to obtain the average titration volume of the potassium dichromate used in the experiment. So when you do a titration, right, the first titration is what we call our rough, just to gauge where is the end point of the reaction, right? When you look at the data, you're going to have to select which ones are the data you're going to use. So let me ask you all something. We got 19.95, we got 20, and we got 80. Which set of data am I going to use in order to find my average value? Which data am I going to use?
19.95 and 20.
Yep.
The volume of solution used, sir.
Yeah.
All those values.
Well, you're not going to use all the values because the first one is 19.95, right? The second one is 20.00, but the last one is 18. That 18 kind of off by almost 2 cm cube. So something is wrong with that final titration that they did, right? So what you're going to do, they said, now remember, usually when we do that titration, we need to find our titration so that they only differ by about 0.1. Right? Plus or minus 0.1. So what we would do, so let me show you exactly what you're going to have to do for this one. Right? And this is not the first time we've done one like this. So let's go back here. They said using an asterisk, indicate the titration data that should be used. So the ones we're going to use, this is 19.95 and this is 20. So I am going to use this value here and I'm going to use this value here. I am not going to use the last one because 18, the difference between 18 and 20 is 2 cm cube. That's too much. What we are looking for is what they call titer values that differ by plus or minus 0.1, right? CSEC specifically says this is how we're going to check it. So we're looking for values that only differ by about 0.1. So I can use titration 1 and titration 2, but not the third one, right? So when they come and they ask you, right, so 1 mark just for doing that, hence calculate the average volume. So average volume of potassium dichromate right, is equal to, so what we're going to do, we're going to take those two values, the 19.95 and the 20. So this is 19.95 plus 20.00, and we're going to divide it by 2, right? Because you're finding the average value. And that's going to give me what, 19.95 plus 20. And what we're going to get there is 19.975, right? But the value we're going to use, because we're only going up to 2 decimal places, it'll be 19.98, right? That's what we're going to use in our calculations. 19.98. So 19.98 cm cube. You all with me so far?
Yes, sir.
Yes, sir.
Yes, sir.
All right. So far, what do we have to do? Right, so is this, so 2 marks for this, that's 9, that's 11, 12, that's 14 marks already gone there, right? This question is worth 25 marks. Now, using the information in C, calculate the average number of moles of potassium dichromate used in the experiment. Now, we know what volume of potassium dichromate we're using. It's 19.98 cm cube, right? So let's just put that somewhere here. So we need that. 19.98 cm cube. That's how much potassium dichromate we use. If we want to figure out moles, they had to tell us something about concentration. So let's go back to the beginning of the question. Yes, they did. They told us the concentration of the potassium dichromate was 0.020. That's this figure here. You see that?
Yes, sir.
Yes, sir.
Now we got to make use of that, 0.020. So the concentration is 0.020 mole per dm cube, right? So to get the average number of moles, we're going to have to say 1000 cm cube of, I'm not going to write out the whole word, so it's K2Cr2O7. 1000 cm cube of potassium dichromate contains how much moles?
0.020.
0.020 moles, right? We got that information based on this figure. That's what that's telling me. So therefore, and this is what you actually use in the calculation, it's 19.98. So it's 19.98 cm cube of K2Cr2O7 contains, and we cross multiply. We're going to say 19.98 multiplied by 0.020 divided by 1000, and that is going to give me right? I'm getting a really small number here, right? So I'm going to have to put my answer in standard form. So it's going to be 3.996 by 10 to the minus 4. So that's what I'm going to put. It's going to be 3.996 by 10 to the minus 4 moles. Please use your calculator and make sure you're getting that same answer that I have.
Same answer, sir.
Right? So 1 mark just for that. Now, lots of students who do chemistry, they have real problems when it comes to moles. They want to avoid it like the plague, but you have to be able to do these things, right? So all I did, I used the concentration they gave me for the potassium dichromate, that's the 0.02, and we know the volume of potassium dichromate that we use. Now, the next part now, from the equation on page 4, determine the number of moles of ions that will react with 1 mole of potassium dichromate. So that's the first equation they gave us here. That's this. From this equation, how many moles of iron reacts with 1 mole of potassium dichromate according to that equation? How many moles of iron reacts with the potassium dichromate? The answer is right there. Nobody?
So just repeat that one more time.
The question asks, go back to the question. Question wants to know from the equation, determine the number of moles of ions, that's Fe2 plus ions, that react with 1 mole of dichromate ions.
6 moles.
The answer is 6, right here. Look at right here. According to this equation, 1 mole of the potassium dichromate reacts with 6, right? Guys, this is something basic that you all should know, right? And you all write an exam in about 3.5 months. So 1 mole of potassium dichromate reacts with 6 moles. It's right there in the equation, right? That's where this number here, that's what that is telling me. So determine the number of moles of ions that will react with 1 mole. So the answer is simply, so you're going to just say, you can just write 6 as the answer, or you can say 1 mole, right? Cr2O7 2 minus reacts with 6 moles Fe2 plus, right? So the next part now, They said calculate the number of moles of iron in the iron salt sample. Now, let's go back a step here. So we know how much potassium dichromate we use in the titration, right? That's this figure here, right? We know what the mole ratio is. 1 mole of the potassium dichromate is going to react with 6 moles of iron, right? And this part is asking calculate the number of moles of iron in the sample, right? So this is what we know. We know 1 mole Fe2 plus, that's from the answer before, reacts with 6 moles Cr2O7 2 minus, right? That's the answer from before, right? That's now. I need to rewrite the equation because I want to figure out, I wrote it the wrong side. Let's write it the next way. Because you want to figure out the amount of moles of iron needs to be on the right-hand side. So what you're going to say there is 1 mole of the Cr2O7 2 minus, 1 mole of the Cr2O7 2 minus reacts with 6 moles Fe2 plus, right? Therefore, how much moles of potassium dichromate we had? How many moles of potassium dichromate did we have in this experiment? Angel, how many moles of potassium dichromate did we use in this experiment?
Sir, 3.996 and something.
Yep, 3.996 is the answer right here. We just worked that out. 3.996 by 10 to the minus 4. So therefore, 3.99, just now. 996 by 10 to the minus 4 moles, right? Cr2O7 2 minus reacts with, right? And we're going to cross multiply. So this is 3.996 by 10 to the minus 4 multiplied by 6 divided by 1. And let's work that out. What we're going to get here is 2.398. We can work with that, 2.398. So this is going to give me 2.398 by 10 to the minus 1, 2. Right? Is that making sense, everybody, or you're all totally lost?
Yes, sir. I
Making sense, sir.
understand.
Right? So what you just worked out there, you worked out how much moles of Fe2 plus you had in the iron salt. That's what you just did. The next part now, they want us to calculate the mass of iron in the iron salt sample, right? Now, they gave you the mass of 1 mole of iron. It is 55.8. So to work out the actual mass of the iron in the salt tablet, right? What you need to do, you need to say 1 mole, right, of iron, Fe, right, has a mass of 55.8 grams, right? So that's the molar mass of iron. Therefore, all we need to do is to take this figure, this answer that we just got here, the 2.398 by 10 to the minus 3 moles right, of Fe has a mass of, and we're going to cross multiply here again. So that's 2.398 by 10 to the minus 3, right? Multiply by 55.8 over 1. And that's going to give me 1.134, right? That's what I get for the answer, 0.134.
So if you mess up the potassium now, like how the mole for the potassium 3.96 by 10 to the minus 4. If you mess up from there, then F and G will be wrong.
Right. So how CSEC corrects, and this applies to all subjects, there's something called error carried forward. So if you make a mistake early in the question, but your process of working the answer is correct, right, they will still give you the mark. So you might only lose mark for higher up where you actually made a mistake, right? But when you're doing some of these mole calculations, the answers from before are important. They impact on your final answer. Now, where are we? So, I don't get lost, right? So H. So now they want to calculate the percentage of iron in the salt sample. So based on the titration alone, right, we just figured out that the amount of actual iron in the sample is 0.134, right? So this is my mass of iron that is actually present. Mass of iron, right, is equal to 0.134 grams. So let's go back and see what is the mass of the tablet, right? So let's go back to the beginning of the question. At the beginning of the question, they said 0.5 grams of the sample, right? So it's an iron salt and the mass is 0.5 grams, 0.500 grams. So mass of this is 0.500 grams, right? So you realize the tablet is 0.5, but the actual iron that is there is less than that, right? Actual iron is less than that. So they want the percentage of iron in that sample, right? So all you're going to do is take the 0.134 and divide it by 0.5 and multiply by 100, right? So let's do that. So percentage of iron, right, is going to be equal to, all you have is 0.134. You're going to divide that by 0.500, because that's the total mass of the tablet, multiply by 100%, right? When you work this out, you're going to get as 0.134 divided by 0.5 multiplied by 100, and that gives me 26.8%. Right. Now, one of the things, I mean, there's a finite amount of questions CSEC could bring, right? You see the question 1 in the chemistry paper. Some of these questions, they repeat. They just change the numbers, but it's the same basic question that you get. Calculation is exactly the same. So this is not the first time I've seen this question, right? So I think there was one I worked, I think it was with the Form 4 class, and the percentage was like 80% or something. So the percentage, right, will change. That's all they changing in the question, but the exact calculations for the question, right? So any question about how we got that percentage?
No,
Yes.
sir.
No, sir.
Right? Now, when we do these questions, please go back, make sure you understand why I did certain things to work these things out, right? Now, let's see if we can answer the rest of the question, right? So the reaction between iron and dichromate is considered a reduction oxidation reaction. Define the term reduction in terms of electrons. Let me see what you all remember. What is reduction?
So reduction can be defined as the gain of electrons.
Yep. Reduction and oxidation can be defined in about 3 to 4 different ways, right? And what they want here, reduction, is simply the gain of electrons. That's all they want. Reduction is the gain of electrons, right? So you're going to put that. So reduction is the gain of electrons, right? So that's my answer here. Reduction is the gain of electrons. Next part. In the reaction, Fe2 plus is acting as the reducing agent. Question is asking now, here what is a reducing agent? What is a reducing agent?
So a reducing agent is sorry, now.
So there are several ways or several things we can see, right? A reducing agent will reduce something, right? A reducing agent is going to reduce something, but we might need to say a little more in order to get him out, right? So here's what we're going to do. We're going to say a reducing agent reduces a substance, right? And is oxidized in the process, right? So a reducing agent, it reduces something, but at the same time it is oxidized in the process, right? Right? You can say, now you just need to put this on the game marks, right? But you can also say, if you want to show them that you know what you're talking about, the oxidation or its oxidation state decreases, right? So anything that sounds like that, you're going to get a marks for it. Right, so I'm gonna put that, so it reduces something, right? But at the same time, it is oxidized. Well, we've done this in class, right? Many times, calculate the oxidation state of chromium. Without calculating it, what's the oxidation state for chromium here? What is the oxidation state for chromium?
+3. Plus 6 then.
It should be +6, right? Cr2O7, the answer is +6. But let me show you how you're working it out. So you're working out chromium. So we don't know what it is. Assume you don't know what it is. So we're going to call it X. So you have 2 chromium there. So it's going to be 2X plus you have 7 oxygen, right? So that is 7 multiplied by the oxidation number for oxygen. Oxidation number for oxygen is taken as -2. And you're going to put all of that equal to my charge here, which is -2. So this is -2. So all we're going to do now, we're going to solve this. So 2x minus 14 is equal to -2. So 2x is equal to -2 plus 14. So 2x is equal to 12. Come across here. So therefore x is equal to 12 divided by 2. So therefore x is equal to +6. Right? That's my working for it. The oxidation number here is +6. So that's what CSEC wants. They want that exact calculation that I just did there. That's what they want. Right? And the last part, they want state one precaution that should be taken when carrying out this experiment. One precaution. What can you all see as a precaution? Last week we did a question where they asked us for precautions as well.
Your reading should be right at eye level to avoid parallax error.
Right. What else? We have a good few things we can say about this. What about wearing safety goggles, gloves, lab coat, those things? As important.
Protective wear.
Yeah, so wearing safety goggles, gloves, lab coats. You need to read your burette at eye level. You need to make sure that your burette is vertical, right? So if you all ever worked in the lab already, when you put your burette up like this, right? You need to adjust it so that it's vertical, not slanted like this, because you're going to get wrong readings, right? So your burette needs to be vertical, right? Some students, when they're doing a titration, they put a white tile under the conical flask to make sure they can see the color, right? That's a precaution you could use, right? The next thing you could do when you're doing a titration, let's say you're putting the potassium dichromate in the burette. What you will do is rinse the burette first with the potassium dichromate, right? In the case of the pipette, you could rinse it first with the solution that you're going to use, right? The next thing is when you're doing the titration, make sure you swirl the conical flask while you're doing the titration, so you get proper mixing, right? That's the next precaution you could use. When you are measuring the volume of the potassium dichromate in the burette, right? Make sure you have no air bubbles. Now, I don't know if you all like had sufficient practice in the lab, but when you fill that burette, what you need to do is to make sure, turn on the tap of the burette first to ensure that all air bubbles come out of the burette, right? That's something that
Yes,
you need
sir.
to do, right?
I had practicals with burettes. I think I did 6 practicals with burettes and things. So
Right. So,
refractive index and reflection and things, sir. I have real lot to write up, sir.
all right. So all of those are precautions that we can use, right? And there's only one mark they want here. So to tell you the truth, anything you put that makes sense, you're going to get a mark. So use goggles, right? Lab coats, right? Ensure to read burette at eye level. Right, use a white tile. Any one of those things will work, right? I'm not gonna put on all of them, right? Because only one they want. Right? So any one of those, and that's it. That's 25 marks.